Let's do a little more on separable differential equations. So as we said, the way to decide if an equation is separable is to try to separate it. Sometimes it's easy to tell, sometimes it's hard to tell, but you do your best and hopefully you don't miss anything. So this equation is separable. dy by dx equals xy. Maybe as an exercise, you can try to solve that one in general. This one, dy by dx equals x plus y, is not separable. So this is the only technique we know, and it's not a great technique because this looks like a pretty simple differential equation. Looks like we should be able to solve it, and we can't with this technique. That's all right. We'll learn other ones later on. But let's do an interesting example with this technique before we move on. Dy by dx is 3x squared plus 4x plus 2 over 2 times y minus 1. And we'll actually make this an initial value problem so that we can fully solve it. So y of 0 equals 1. Okay, let's see what happens. So we try to separate this. It's not hard. Multiply both sides by dx and multiply both sides by 2 times y minus 1. dy is 3x squared plus 4x plus 2 dx. Technically, these parentheses are required for the integration. That's a small enough notation thing that you will not lose points on a quiz for that. Okay, integrate both sides. We get y squared minus 2y equals x cubed plus 2x squared plus 2x plus some constant c. You only need the constant c on one side. And then we do have the initial value of 0 comma negative 1, so we'll sub that in. Negative 1 for y, so that's positive 1 minus 2 times negative 1, so that's a total of 3 on the left side. And then on the right side, we have 0 cubed plus 2 times 0 squared plus 2 times 0 is 0 plus c, so c must be 3. Okay, so then we sub that back in. We have y squared minus 2y equals x cubed plus 2x squared plus 2x plus 3. We call this an implicit solution. We've seen that once before when I did my complicated separable differential equation example last week, meaning I don't have it as y equals a function of x. This is probably nicer to look at than anything I could get this, any explicit formula I could get this in. This one we actually can get an explicit formula. Sometimes we can't. Like if this were y cubed, or certainly like y to the 7, that would be a lost cause. We could not get into an explicit format. But this one we can, because this is actually, we can think of this as a quadratic equation in terms of y. If this is all constants, let's just collect that all onto the left side so that we see it. X cubed plus 2x squared plus 2x plus 3 equals 0. If we think of that all as our constant c, then this is a quadratic equation, and we can use the quadratic formula. Let's do that. So y equals negative b, right? B is negative 2, so 2 plus or minus the root of b squared, so that's 4, minus 4ac. A is 1, c is negative this thing, so we're actually going to get minus, and minus is a plus, 4 times this thing, x cubed plus 2x squared plus 2x plus 3, all over 2a. A is 1, 2. And actually we have a factor of 2 everywhere. These 2's, and actually if we take a 4 out in front here, the root of 4 is 2. So we can cancel out 2's everywhere from top and bottom. And y is 1 plus or minus the root of, we're going to be left with 1 plus this thing. So it's just going to be x cubed plus 2x squared plus 2x plus 4. Okay, we don't usually like this plus or minus. That's not a function. But actually, we can check our initial value again. Y of 0 was 1, right? Let's sub that in one more time. Sub 0, 1, 0, negative 1. So y is negative 1 equals 1 plus or minus the root of 0 cubed plus 2 times 0 squared plus 2 times 0 is 0 plus 4, the root of 4. And actually we see that this has to be the negative part, right? Because 1 plus root of 4 is 2, that would be 3, is not equal to negative 1. So in fact, for this initial value problem, the solution is only 1 minus the root of x cubed plus 2x squared plus 2x plus 4. Okay. Question. Can we sketch the slope field? This is certainly harder to sketch the slope field than like the first one we did, which was dy by dx equals some constant times y. That was pretty easy to sketch the slope field. We could do a constant plus or minus a constant times y. That was also not bad. We just shifted it up or down. This is a lot harder. Let's think about a few things. So we may not ask you to do this on a quiz, but you should be able to reason through a few things. So let's see. First of all, we know if y equals negative, or y equals 1, the denominator is 0. So that means dy by dx is undefined. I can sketch that. Let's see, here's y. Here's x. Okay, so when y equals 1, I have undefined slope, so I just have little vertical lines. Okay. And then, I don't know, maybe I can get the sine of the slope. So what happens? Let's just look at the top for a minute. 3x squared plus 4x plus 2. I'm going to pull out an old algebra trick, and we're going to complete the square to look at what the sine of this expression in terms of x is. If I factor out a 3, I get x squared plus 4/3 x. So half of that is 2/3, and then squared is 4/9. Right? And then if I distribute that 3, that's 4/3, and I need it to be 2, so I'm going to add another 2/3 for a total of 6/3, which is 2. Check that this expression is the same as this one. All I've done is complete the square. What's nice about that, this is now x plus 2/3 squared. Check it out, expand it, make sure you agree with me. Now this part is greater than or equal to 0. So this whole expression is greater than or equal to 2/3. So the numerator is always positive, which means the sine of the slope depends completely on y. So let's see, when y was 1, it was undefined. If y is greater than 1, then dy by dx is positive, and when y is less than 1, dy by dx is negative. Okay, so I'm expecting some sort of positive thing up here and negative thing down here. And then I'm going to cheat, and I'm going to know that the graphs of these guys, because these are my solution curves, the plus or minus, will look, it's got a root in it, and if I go on Wolfram Alpha or something and graph it, it looks like that for the plus, or that for the minus. So then what I'm going to do is I'm just going to sketch out these solution curves. Because if I follow the slope field, that is what happens. I end up sketching out solution curves. So I get something like that. And you do get, this is not all one solution curve. It does stop here because we have an undefined slope. So I get a top half and a bottom half. And let's just check out what happens at this 0, 1 point, the one that we solved for, 0, -1. Let's see, we're here. So we are on the bottom half of a solution curve, which is good. We took a negative sign, and then we took it, I don't know, from somewhere around here. and then the top half is a different solution curve. So this orange thing going through 0, -1 should be a rough sketch of that curve.